We want to get to the bottom of the definition of thought. What is thought? How do we define thought? That's the question, okay? It's $1 million question because it's, I like to define words. I spend a lot of time defining words. This one's a hard one, believe me. It's a tough one. Anyways, the way I'm going to get there, I'm going to try to get there. I hope you don't have too many illusions you're going to get an answer today, but we're going to give it our best shot.
Yep.
The way we're going to get there is by asking questions. And maybe by answering those questions, we kind of, zero in on the final definition of the word thought. Thinking. So let's find out how that works, okay? Here's the first question, okay?
Well, before you start,
Yeah.
Isn't that kind of how you define definitions? A definition excludes everything that it could be.
Yeah, in other words, what you want to try to do is not confuse other things that could be confused with that word. You have a given word. You don't want it to be the definition to be so broad that it encapsulates so many things that people don't really know which one you're talking about. It's got to be very crisp, very precise, as much as possible, right?
Do you do it kind of like do you know what a differential diagnosis is?
Uh-huh.
Is it kind of like that where you throw everything against the wall that kind of falls in the same ballpark and then you start kind of narrowing in on the definition?
You kind of brainstorm everything that fits the mold and then try to find out how you can define it in such a way that you get rid of all the stuff that you don't want up there.
It's like a surgical cut.
But the end result has to be that you can use it consistently. Then it's a scientific definition. Okay, so let's start here. This is our first question, and it's got to do with this. Is who, what, you can go either way. Is who, is you, a question of physics. Is what is you, right? A question of physics. Are you your body or your mind? How's that for a starting question? Okay?
Sounds like a koan. Sounds like something a Buddhist or something would ask. Who are you?
Yeah, it's kind of like that. I mean, who are you? Are we? And we have the reason I asked that question is: are we talking about physics? Are we talking about philosophy? What are we talking about? Right? Psychology, psychiatry. What is it? And all I can do is give you my ballpark idea on that, and that is physics deals with objects.
Yeah.
So if someone says, Bill, you are an object, I would say no, I'm not an object. Bill is not an object. Man is an object, okay, but not Bill. Bill is a comparison. Bill, I said Bill because I'm comparing Bill against Joe and John and Tommy. That's why I'm saying Bill. Otherwise, I would say man, because what we're interested in physics are not what the guy's thinking or who did the murder or anything like that. We're interested in the physics of it. Man killed a woman. Okay, that's the physical part. You can't say, oh, Bill, because he was thinking and because of this. That has nothing to do with physics. Mm-hmm. Physics only has to do with the actual event. How do you explain what happened as far as the event is concerned? You say man killed a woman. Then you're okay. See, you get these this fellow. His name is Frege, Gottlob Frege, and he said Socrates is a proper name that refers to an object. Absolutely not. He's saying Socrates is an object, and he's going to put him in a sentence and do different things with him. No, Socrates, we name him to differentiate him from Plato and from Aristotle, right? And what we're doing is a comparison. We're saying, oh, Socrates said this, but Plato said that. That's essentially what we're saying. That's got nothing to do with physics, first of all. And second, the word object belongs exclusively to physics. No one else has a right or an authority to define it. Only physicists.
Can I give you a challenge to that real quick?
Oh, yeah, go ahead.
Maybe, just maybe.
We have a maybe today. Okay.
When we talk about the sun.
Yeah. The son of a gun?
The sun isn't really, is like Socrates. Because it's just one of many stars.
Yeah.
Just like Socrates is one of many men.
Yeah.
But we do talk about the sun a lot.
Yeah. There's nothing wrong with using the word sun to refer to a star and say, I use it sometimes as well. It's kind of informal. the important thing here is that we have to distinguish physics from the whys, the reasons, right, and purposes of philosophy. In other words, we're looking just at what happened. And if you say sun, because you're specifically referring to our sun, but you're really implying that any star can do whatever the sun is doing, shining or whatever it's doing, right? Then you're really talking about star.
Yeah.
But you're using the sun as an example, and there's nothing wrong with using Socrates as well. But when you get down to the nitty gritty,
we don't care if it's Socrates or Plato or whoever.
Right? Because for physics,
for physics,
okay?
But I think it's because when in coding, there's this concept called a singleton, which is there's only one of it. So there is only one our sun, there's only one Socrates. But when you're talking about physics, you don't care about, there's nothing that makes our sun or Socrates so special that it's relevant to physics.
Exactly. We're looking at the man. The only object that had a name was Adam, because he was the first guy and there was no one else around. So he was, and I guess Eve for the woman.
Yeah, but we're not talking about them in physics.
Right.
We don't care about them.
No, and that's why they say the word Adam means man. So God made man, God made Adam. That's kind of like a synonym there, right? But the point here is that that's the way you're supposed to use objects in physics.
Yeah.
And the question is, thought doesn't sound like an object, doesn't sound like a thing. And so the question is, does it even belong in physics?
The question...
No, the word thought, does the word thought even belong in physics? I mean, is it the job of a physicist to investigate, to analyze the word thought or the meaning of them? Okay, justify it.
Well, because assuming everything is a physical process or you could call it an emergent property of atoms or whatever you want to call it, whatever phrase you want to say.
Yeah.
Then eventually most questions could be boiled down or could be seen from the coin side of physics. Almost any question you have could be a physical question.
Yeah, but again, we're not talking about the outcome, and we're going to get into that in a couple minutes.
Let me put it like this:
we're looking at
thought is something that's happening in the brain. So you could go down to the physics of it and be like, what generates thought? Which atoms? Which molecules? How is thought generated? That would be a physics question.
Right. So that portion of it is
exactly
because that's the physical part. But the thought itself, what it is, this abstraction that comes out of our brain, I guess it comes out of. Do you see my thought?
Yeah, language falls apart real quick when we talk about this.
Yeah, then that part, I guess, would not fit into physics. The part that fits in there is, how is it manufactured? Well, it's manufactured maybe in the brain. Is it that like a chip, like a computer, etc.? Those are questions that a physicist can answer or should try to answer, but not the thought itself. Okay, why did I go over there? Why was I thinking about this or that? That doesn't concern physics. Okay. So here we have a question. First question, I guess. First important question. That was an important question, by the way, but this is a second important question. Here we're going to compare the brain to a computer. In other words, we have the head, right? Head contains the brain. Brain contains this software, you can call it. It's a mixture of mind, education, personality, so many things you can fit in there. I just put 3 of them there. And, that more or less mimics what you see in a computer. That would be kind of like the software. And my best description of that is that it's like the will or volition. You will yourself to do something or to think something. You can change your mind from one second to another, think about something else. Your mind also tells your body what to do. So I say that the software is like will or the volition. It's how you're programmed inside because of your education, how you grew up, your personality, your DNA, how it's working inside your brain. So many things involved in there, but it's what instructs the matter to do something, to act in a certain way. Okay, even matter meaning your own brain. It's just triggering your molecules in there to act in a given way. And then we end up with a product. In the case of computer, you're talking about the information that comes out of the computer. And what comes out of your brain, out of all this process of will, volition, your personality, all that, moving all the neurons in there, is something we call thinking or thought. I think this is the best analogy I can have, for these words. And so the question is, what do you think of this? You think it's on the right track here? Is this a good analogy? Computer with a head, hardware for the brain, etc. Is that what we're talking about here? Is that how we're going to?
I mean, as a first pass, it's not bad because I can't find anything. Nothing sticks out completely wrong off the top of my head.
Are these synonyms? Mind, thought, all the words at the bottom.
No,
thinking,
for sure those aren't.
Consciousness, spirit. Because
I think conscious. Well, I mean, one that I would add down there that is attention. That one's also kind of missing because there's consciousness and there's attention. Like, for example, you could be hearing a lot of sounds going into your ear, but you are paying attention to one. So is there a difference there?
Well, all you're saying is that on the recorder inside the brain or on the screen, whatever, there's only one sound at a time or one image at a time.
It's hard to, I guess, but it's your brain is there's a lot of sounds and a lot of visions going into your brain, but you're only paying attention to one. So whatever that paying attention is another characteristic of thought or brain activity, whatever you want to call it.
Is it possible to think about two things at the same time?
No, impossible.
Half the brain thinks about this, the other half thinks
You're jumping
about that.
back and forth. It's like multitasking. You can never. I mean, it's hard to talk about multitasking too because you could be washing the dishes and thinking something. That's your move. It's like I can move my arm one way and move my other arm the other way. That's multitasking technically, but your brain. I guess
two things at the
what
same
I'm saying
time
is the
here.
projector in your brain can only do one thing at a time. It can only focus on one thing at a time. You can have more things running in the background.
So you're saying that's unconscious or whatever. That when I'm doing this, I'm not even thinking about my hand. I'm thinking about this beautiful girl I saw at the beach, and I'm moving my hand. So
you can walk.
What's in the field of view?
That's what I mean. Multitasking is a mechanical thing where it's like you can walk, chew bubble gum, sing, but your attention can only be on one thing at a time.
Okay, I'm not thinking about my hands, right? Because I move them mechanically. Somehow I put them in motion. They're working.
You can do this without thinking about it, but you can only think about one thing at a time.
I like that. Thinking. What do you mean?
Okay, but let's be more specific.
Who is thinking about? But who is thinking about my hands?
I like paying attention more because that one's a little more specific. Because the whole topic today is defining thought. Because that's obviously a hard one. But attention is easy. We all know what attention is. Okay, what attention is what's on the projector, what you're focusing on.
Yeah.
So that is something that can only be on one thing at a time. You can't focus on two things at a time.
Okay, let me play devil's advocate here. We have a screen. We have a split screen. Okay. One projector on half the screen, another projector on the other half, right?
Yeah.
And so there's two things going on the screen, half and half, right? Or it could be a circle surrounded by something, anything. Could be different ways, right? You divide them up any way you can. You're focusing on the screen, but the screen has two images or even unrelated images, right? And the question is, you can only go from one to the other. You can't focus on both of them at the same time. That's what you're saying?
Yeah. So attention is easier to define in that sense, or it's easier to grasp. Now that's separate from thought, because you can. I mean, if we're saying thought is just brain activity in general, then it gets hard to grasp. Then it gets hard to grasp. But it depends on what you want to encapsulate with the word thought or thinking.
But I like the word attention. You may have hit something there. We'll find out in a minute. Yeah. Okay, so I mean, if the brain functions like a computer. I'm going to go relatively quickly on this. I went over this the other day, but we need to know how a computer works, or at least how a chip works, because we're going to try to relate the brain to the computer, or you could say the neuron to a transistor. Here's a standard MOSFET transistor. Okay, and what are we staring at? Well, we're staring at this device that represents either a 1 or a 0. That's all it does. And the way you do that is you have this phosphorus dope gate. It's got phosphorus because it's got an extra electron. This is the explanation you get from quantum. Have an extra electron on its outer shell, valence shell, and so that extra electron, if you put it inside the silicon, you have one more electron moving around than the silicon can afford. And if you put boron, you see that it's positive. Why? Because it's got only 3 electrons in its valence shell. That means it's going to be short on one electron. The whole thing, the substrate there, it's going to be missing an electron. And here you can see a better picture of that. Normal silicon, if you look at that silicon in the center, it only has 4 of its own, but it's receiving 1 from each one of the silicon nearby, and so it's got its outer shell filled with 8 electrons. You look at the boron and you see that it's missing an electron because it's only got 3. So you have these, what they call holes, and the holes begin to move around. Okay, so as an electron fills the hole, it leaves a hole behind it, and the holes are moving in the opposite direction to the electrons. And then the phosphorus, since it donates an extra electron, you can see there what happens. You've got an extra electron that's going to move around because it has no place to go. Okay, and so this is how they give electrical characteristics to the silicon. They either implant boron or phosphorus. Okay, so that's in general terms. Let's see how this thing works. Here's a here you have a MOSFET. It's clean, nothing there. Okay, we're going to apply a voltage. Okay, so here it is. We're going to apply this voltage. Supposedly, what you're staring at are electrons that are being sucked out from the gate. The pink / reddish one on the top, that's the gate. You're going to apply a voltage there. You're going to draw electrons from the light blue area, which is the boron doped area. And you don't want them really to go through the dark blue one there, which is the oxide layer. It's the insulator. You just want to draw all those electrons close to the border between the light blue and the dark blue. Okay, that's what we're trying to do here. And we're going to create what is known as a channel. This is the N channel. Okay, so all the electrons are going to pile up at the N channel region. Okay, and the next here you can see maybe what the general notion is. All the electrons piled up there. Okay, that's the idea. And what you're going to do is create this N channel so that when you apply a voltage between the source and the drain, okay, what you're gonna see is that you got a lot of electrons there, and you're gonna have a current. Okay, so let's apply the voltage there, and this is more or less what they think is happening inside the chip. You have the voltage on the drain, on the gate, which is the one on the top, the pink one, and then because you apply the voltage between source and drain, you have all these electrons moving. The electrons are moving in this case from left to right, and the holes are moving in the opposite direction. Remember, when electrons move in one direction, they leave a hole behind it, like I was explaining last week. Okay, so this is in general how these things are constructed, or what the idea behind them is. As soon as it's turned on, the transistor is a 1. If it's not turned on, it's a 0. Okay. And so what they do with it, oh, by the way, here's our version of that. I showed it the other day, but here it is. We're saying it's all torsions. It's got nothing to do with little beads moving, back and forth. Okay. And so if we apply the voltage, what we're doing is creating a torsion, and the torsion it's not strong enough to penetrate the dark blue area. It's just strong enough for it to trigger the electrons to spin in the N channel. And once we apply the voltage between source and drain, what you get is this. You have a torsion going from source to drain, and it's all done with torsions. I put a light torsion there in the dark blue area because I think the oxide layer does not completely isolate, one region from another, but that's more or less trivial. The point here is we say that the way this thing works is through torsion. Merged electron shells of different atoms. They're merged to each other, and what you have a torsion going from one region to the other. This is going to be important because we're going to explain using this same mechanism how the neurons in the body work, including the neurons in your brain. So that's the reason I'm showing this. Okay, so this is how it works. Now, what do they do with this? I mean, you're saying, how does this relate to thought, to the brain, etc.? And so let's relate it so that you get a better idea and gives you some homework, something to think about this week. Think about thought, okay? Okay, here it is.
Whoa.
You have this, you have all these transistors. We have 8 transistors there at the top. These are, we'll call them MOSFETs, metal oxide semiconductor field effect transistor. Got this long acronym, MOSFET. So you got 8 of them, okay, the red ones there, the red numbers. And what we're going to do, we're going to try to figure out how do we program a 1? How do we create a 1 on a computer? I think that's quite simple, right? And so the way we create a 1, you see the numbers on the top, the blue ones, 1, 2, 4, and 8. In column 1, okay, we're going to have that transistor turned on, and all the others are going to be turned off. Okay, so we have a 1 because that's what that column represents. If you want a 2, well, you move over to the column 2 there, the blue 2, and that one's on, all the others are off. If you want a 3, then you get the 1 on the 8 column and a 2 on the 7 column, and that's how you get a 3. If you want a 6, well, you got to get the 2 that's on top of the 7 and the 4 that's on top of the 6. You add them, and guess what? You get a 6. And the same with a 9. You get the 1 from the 8 and the 8 from the column 5. Those 2 are on, all the others are off.
So you're saying a byte, 8 of these 8 transistors makes a byte?
Yeah, what I'm showing here essentially is this is a conceptual thing so that you get an idea of how because what we're going to do, we're going to get a result from the computer. We say, give me a 1, and that's how it gives you the 1. Say, give me an 8, or a 9, or a 6, and then, this is what the computer is doing. It's turning one transistor on and the other one off. And with these combinations, they can create not only numbers, but words or whatever.
How many transistors does the computer have?
You want me to count them?
Stars in the galaxy?
More or less. Okay, so I just want to give you a big picture of how this works. The question now is this how our brain works? Do we have neurons that are zeros and neurons which are ones, right? Is that what we have in there? And so this one turns on, this one turns off. Now, in order to turn a MOSFET on, you need between 2 and 4 volts, okay? If you have like a volt and a half, or even half a volt, it doesn't turn on. And so if it doesn't turn on, it's a 0, okay? So anywhere from 0 to maybe 2 volts at most, you would get a 0 at that transistor. The other one has to have between 2 and 4 volts, now you get a 1. Okay, now, and the question is that how our brain works? You have these neurons, right? And let's assume, and again, we do it through torsion in our case here, our explanation. Let's assume that the neuron is torquing, so the molecules in there are torquing, taking signal to another neuron from there to another, and they're all connected and they're all torquing, right? And so the issue is it that maybe here one's twirling and is connected to another one that's twirling, and that's what thought is. It's creating this ones and zeros. Is that how our brain works? Binary system, or is it in some other totally different way? I mean, this is the question that's in the background, because we're going to try to define thought, and we're just trying to figure out if the brain in any way matches the computer. If what we discovered in the 50s and 60s, which is, the computer itself, how a transistor works and so on, how to make use of that, did we discover how the brain works by doing so? Okay, that's what you
mean, just a small addition to that. You can tell just by the size of a brain and how much information it stores, memory it stores, that there's definitely a lot of compacted, like it's compact. It can hold a lot of gigabytes for its space, more than we can with computers.
The head weighs a lot, okay?
Yeah, but like just if we're talking about space, It can hold a lot of memory.
Yeah.
So it's doing something very efficiently.
And they say Neanderthals had more bigger brains on the average, right? Slightly bigger brains than we do as humans, but I guess they weren't as smart as we are. Maybe they had the potential of being just as smart, but I guess because they didn't develop technology, I guess their brain didn't develop beyond a certain level.
So
right?
is thought just the electricity in the brain, or are we going to add the spirit?
We're getting there. We're getting to the spirit. Okay, we're getting there. Okay, here's question number 3. It's a follow-up on that one also. Does the brain work like a chip? Is a transistor like the neuron? Is a group of transistors like a group of neurons? Okay, and the other day I showed, last couple of weeks, I showed the chemical, because they call it an electrochemical process. And the question is, if this has anything at all to do with the chemical part. I can accept an electromagnetic process, but the question is this electrochemical? And I'm saying it can't be chemical at all. Not the thinking part or the pain part or the touch. You know, when you touch something, you feel it instantly. Those can't be chemical, because if you touch my toe, I feel it immediately if I'm not quadriplegic, right? I can feel it immediately. And so the question is, how did that touch go all the way to my brain and say, oh, I know you touched my toe?
Yeah.
You know, there's a lot of neurons between my toe and my head. And the question is, how did I get there?
I mean, it's eerie when you think about how fast it is.
In fact, that's why I'm saying it's got to be a torsion. Torsion is the fastest thing imaginable. Light is a torsion. Electricity is a torsion. And guess what? I'm saying this is a torsion as well. And here you have the quantum version I showed the other day. You have the arginines. This is this sailboat. Really more than a sailboat, it's more like a submarine because it's going through the water. That greenish region, the axon there, is fluid. Okay.
What are we looking at?
And what you're staring at is the pink ones that are coming, pink balls that are falling in there. Those are sodium.
No, but what are we looking at right now?
Okay, we're looking at a neuron.
Oh,
sorry. Yeah, okay. So this is a neuron separated from by a synapse from another neuron.
A synapse is just a hole?
Yes and no. They haven't figured that out. There's two versions out there. One is that it's empty, and other people say that it's not really empty, that you have something stretching across. Others say it's not stretching, it's flowing across, and that's what I'm going to explain right now.
But there's no consensus on what the synapse is.
They're not exactly. They're working on that. There's no consensus.
It's a gap-like.
Yeah. And here you see, anyways, even if they could agree, we have a problem anyways. Again, you have the pink balls. Those are the sodium coming in there. You have the rhomboid there, the diamond-shaped ones. Those are the potassium going outwards, and they go in and out. This is constantly flowing through the membrane of the axon there. But the important part is what's flowing through the river there. You know, that's arginine moving from left to right. It's going to get close to the synapse, going to trigger this other molecule, the glutamate, to go across or stretch across, one of the two, and the process begins again at the next neuron. Okay, now think about 1 billion neurons. This happening from neuron to neuron. I don't think this is going to go at the speed of light. No way I can imagine this going at the speed of light. And what we have a different proposal again, and we're saying it's a torsion. And so we have the arginine molecule, which is, again, it's a CHON, what I call CHON, carbon, hydrogen, oxygen, nitrogen, CHON, right? And all these molecules are CHONs, both arginine and glutamate. There's just minor differences between them. But I'm saying they're all connected, and what happens when I touch your toe, all these take the torsion from your toe all the way to your brain. That's why it's so fast, okay? At least that's my explanation for that. I'm saying it can't be a chemical process. It does have to be some kind of electrical process, because this is electricity under our version, right? It's a torsion. And it's a whole molecule that's spinning and taking the torsion from one end to the other. It's all connected, okay? And if you're quadriplegic, what happens? You know, suddenly it's severed somewhere, and you don't receive the signal. In fact, a fellow was wondering about that. I said that if you don't have a brain, you don't feel pain. He didn't believe me, or he had a little bit of a doubt about it. And so I showed him the legs of a frog, okay, the other day. And they cut the head of the frog. The frog has no brain. And, here's the legs just sitting there, and they pinch the leg or throw some salt, or you can also use electricity to give some stimulus there, and the leg moves. So the muscles, the nerves, they're working. The question is, does the frog feel pain? And no, because there ain't no frog. That's
Just a leg.
Just a leg. And I'm sure that could happen to any of us. We're down, we have no head. I'm sure they pinch you. Your leg might move. Does that mean you feel pain? And I'm saying, no, you need the brain to feel pain. And it's hard for us to imagine that, because we're saying, how come when you pinch me, I feel it down here, my leg? No, you really feel it in your brain. Quadriplegic does not send the signal. You can pinch him all you want. He won't feel anything.
Aren't there also people who can't feel pain but can still move?
I guess. I don't know.
It's also a weird one. There's a certain illness where you can't feel things, so they have like timers on when to eat and when to do things. Like they have a timer.
Isn't that like quadriplegic?
No, but they can still move.
Huh.
Like they have to have timers on when to stand up because they can't feel the soreness in their butt.
But then how does the brain move those parts of the body if it seems like there's no connection?
I don't know. Look it up.
I want to
That'd be a weird one.
Okay, there. Okay, so here we have the comparison between pain according to quantum and pain according to our version. Could be pain, could be touch, could be anything, any sensation. If you pinch the guy on the toe there, according to quantum, all these molecules that travel along the neurons. I put only 9 neurons there so that you can get a feel for how long it might take for the signal to go through just 9 neurons. Imagine billions of them. And what we're saying is they're all connected, all these molecules, and what you're doing when you pinch someone is you're creating this torsion that goes instantly to your brain. And I think that's why touch and pain are, you could say, instantaneous.
It's almost like when you talk about a torsion, I always have to think of if you have a steel bar that goes from your toe to your brain, and you just grab the end of it at the toe, you turn it,
right.
The top instantly turns.
Right, and that's the point. Whereas imagine something that had to travel from your hand, where you have imagine something had to travel through the tube.
Well, but just as devil's advocate,
yeah.
You know how a hydraulic press works.
Yeah.
So technically, you could still have instantaneous movement with a hydraulic press, and that's just fluid. So if you push on this, the one here instantly gets pushed because it's under pressure.
Okay, first of all, they have to be connected physically.
Just imagine a tube, and
you
push,
squeeze
like a tube of toothpaste. You squeeze the bottom, instantly it comes out the top.
First of all, it's different to send a submarine through the water.
Yeah.
Okay, that's the first one. The second one is, you can press water and say, well, if I press the water over there presses on something else, right?
Instantly.
That's what we're saying, because they're all connected, and you're pressing here, and it's doing it over there. Yeah. That's not what these people are saying, because remember, electricity doesn't work like that. Electricity, according to them, is the flow of electron beads.
Yeah.
So I push this bead, that bead jumps over to the next atom, pushes the other one out, or the other one leaves a space and this one fills it. It doesn't matter. That's got to be a very slow process if we're going to do that. If we're going to do electricity, like metal electricity, right?
Yeah.
But that's not how the body works. The body, they say, is molecules that are moving through the river, really underwater, right? Because it's all full of fluid.
Yeah, no.
So you have this molecule moving over here, hitting the other molecule that goes across the synapse.
Yeah, no. You're talking about the rock within the water moving, but that's not analogous to the
right.
hydraulic, so
right.
It doesn't work.
There's no way that the current explanation of biology can explain pain or touch, because you touch me, it's instantaneous. And the question is, you're saying you touched me in my finger, and it went from neuron to neuron, all these glutamates and all these arginines, and they're pushing each other one right after another all the way to my brain.
Yeah, it's not instant.
It's a little difficult to believe.
It would have some lag.
Yeah, 1 year I would feel the pain.
You get punched and you feel it a week later.
Okay, so the brain works more or less, we think, in the same way. Here you have the quantum brain on the left and the our brain on the right. Again, we're saying it's electricity. In other words, by electricity, I mean that we have torsions of molecules. The molecules are torquing. They're all connected.
When you talk about molecules that are torquing, you're saying it's like a, I don't want to say chain, but it's
kind of like a chain.
It's kind of like a chain, but chain makes it sound like there's some slack. But here you're saying there's no slack, because when you twist a chain, it's not like you feel the other end of it instantly because there's slack between each chain link. But here the chain links are almost like fused
rigid,
onto each other,
like rigid or something.
They have more influence on each other than a chain link does.
Yeah,
because there's gaps in chain links, but with molecules, the way you have it in yours, it's almost like they're like this. So when one turns, the other one turns with it.
Because they're all connected.
But that's different if you have like a chain link. This one can turn
no,
a little bit.
We're not saying the link. We're saying that the molecules are, merged.
They're like
with
grabbing each other.
Like grabbing each other. And so you have this long chain of molecules, and you turn one and the whole thing turns to a certain degree.
It's more like a bar than a chain.
Yeah, it is. That's what I'm saying. It's and it's not like there's loose links in there. It's like, in a sense, it's rigid because you're talking about an electron shell, because ours is a ball. This is our atom, by the way.
Two yarn balls that are in each other,
right? And so you're talking about something like that, where one is connected to the other, and when you turn one, the other one turns instantly, and the whole line, the whole sequence, it turns automatically. Because a single torsion, and the guy feels it at the other end. And I think the best analogy that I always come up with, you take a rope, and tie it at one end of the room and the other one at the other end, pull it as tight as you can. And as soon as you torque it, the signal goes instantaneously to the other side. I think that's more or less what's happening inside the body. It's got to be something along those lines. Anyways, our proposal is not traveling. Our proposal is torsion. And I think with torsion, you have a better chance of explaining what's going on inside the body. Anyways, I talked the other day about, the pigeons, and they have this magnetic field inside their brains. I can't say that that's how thought works, because even though it's tempting to think that that's the way thought works. The problem when I see that with this and our brains is that the threads that swing around, they don't extend very far beyond the skin. And so how would one side of the brain communicate with another if it depended on a magnetic field?
Or wouldn't they just have to affect the row next to it? What I mean is one end of the brain doesn't have to talk to the other end. It's like one end can talk to the neighbor.
Relay.
Yeah, that.
Well, that's a possibility. That's one that has to be investigated. In the case of the birds, the reason they can fly is because you have the magnetic field of the Earth interfacing with the magnetic field of their head, but we don't have that in our brains. We get lost.
And we might have something similar.
Yeah, well, I don't know. The question is whether this is,
I mean, let's put it this way: if do you think you would feel any different if, like, God came and turned off the magnetic field of the Earth? Do you think you would think differently or feel
differently?
Today
I was thinking when I was running, because, when you run in I run in circles, right? And so I run in one direction and I get kind of dizzy. Then I run in the other direction. My brain kind of makes an adjustment. I'm saying, is it that the magnetic field of my brain is interfacing with the magnetic field of the Earth like that of a pigeon? I mean, I don't know. Why am I getting dizzy?
I don't know how dizziness works either, but I think that has to do more with like fluids in your brain.
I think so too. But I mean, it's kind of weird that, I don't think, because you could lose your orientation and then recover it after a few seconds, right?
Yeah.
And the question is your brain also somehow, your magnetic field in your brain also to some degree interfacing with the magnetic field of the Earth? It's sweeping right through us.
I'm sure it's doing something.
Is it?
Like if
maybe
we
we're
tell
not sensitive enough to make use of that,
I don't know,
like the pigeons.
But I'm saying if the pigeons can make use of it, for sure other animals are doing it, and maybe we are too.
There are like the sharks, and there's a whole list of animals that.
I'm just
can do
wondering
that.
if we just magically transported you to the edge of the universe, where let's say you're
Please
still,
don't.
let's say you're still warm and you know and pressurized, right?
Okay.
But let's say basically all I'm just saying is if we teleported you to a place where there's no magnetism flowing through you besides your own, how different would you feel, or what would you feel? Would you feel any different?
I don't know. I'm saying that life may not have started here on Earth if it weren't, among other things, gravity. But if the magnetic field was not there, I think we wouldn't be here. I think the magnetic field is part of the necessary ingredient for life.
Well, it's one of those.
Now that's
again, it's
a belief.
Again, it's one of those like immutable facts like gravity. You can't. It's
well,
like
it's a little different than gravity.
What I mean is, it's one of those.
Like you said, do we need the magnetic field? Maybe we do.
It's one of those unfalsifiable thought processes where it's like you can't remove gravity just the same way as you can't remove magnetism. So it's hard to say what part gravity or magnetism had to play on us.
What do you mean you can't remove either one?
That's what I mean. Since you can't have a world without magnetism.
Or gravity.
It's hard to say what effect they have or don't have.
Well, to some degree, because remember we have the astronauts go out there in outer space, and suddenly, because they stay there 6 months,
they atrophy.
Part of that is gravity, but the question is, what is the effect of magnetism on them as well? Because they're not hit with the same magnetic field that we are here on Earth, and so all these things. I don't know. We gotta research those things, Anyways, let's keep going here. We have question number 4. Okay, and what is this question? It says, each word in a sentence has meaning.
Okay.
So we have, take any word in the dictionary. It doesn't matter how long, how short, right? Each word has meaning. However, you make a sentence with these words, and you end up with a different meaning. Okay, so the meaning of one word, the word went, is not the same thing as I went to the store. That's a totally different concept than just went. And so here you have this stone, all these words that we put together. These are the stones. And with all these stones, we build a long stone, a longer stone, a series of stones.
I mean, it's like a soup, right? When you're eating a soup, technically it's all the same flavors, but combined,
right?
You accept them as a different thing.
Right, and the question is thought just one word? Is it like digital, right? Or is it analog, like, something one right after another, and you need the whole thing for the thought to be there?
That's
right?
a good question.
Right, and you got paragraph, story, and book. I mean, where are we going to stop with what is a thought?
You came up with these questions?
Yeah, I'm coming. You don't like them?
No, it's a good question.
Okay.
I guess one question that kind of behooves is, where does one thought end and the next one begins? When do you call it a new thought?
Yeah, because let's talk about a string, okay? We'll call it a string. So we have a word, and we have many words, and those words form a string. We'll call that a sentence, a string, whatever. Now we have all these strings, they form a paragraph. We have all these paragraphs form a story or a tale or whatever.
Yeah.
And so the question is, a story could be one concept, one thought. I thought the thought was the paragraph. And the other guy might say, well, it's not the paragraph, it's just the line, just one line. And the other guy might say, no, it's just one word. But with one word, we can't do much. We turn it into a sentence. That's a lot better than one word. But then you have a paragraph. That's a lot better than one sentence. And then you have a whole storybook. That's better than one paragraph.
I mean, you're kind of blowing my mind a bit, because I never extrapolated, like, if you take all the thoughts one person thinks in their whole life.
Oh, my God.
Exactly, right? Let's say that's the full span of thought that they ever had. I never zoomed out to that extreme where it's like, okay, now that might give you some more perspective on what it is. Because if it's just chaining from one to the other, maybe we're doing thought a disservice by cutting it off there and saying, this is a thought, this is a thought, this is a thought.
Are you saying that's you have many thoughts in your life as neurons in your brain?
Or is it all just one thought? Depends on where you cut it off, but I never zoomed
And
out.
then,
like
and
that.
then, of course, you got memory. The issue of memory, which is another.
that
is
makes it hard.
Yeah, involved with thought as well.
Well, again, but the question I always throw is are we talking about one thought, like me generating this phrase now, or are we, because that's one conscious thought. I think we can all say that that's a thought. But when we're talking about just brain activity,
Yeah.
there's a lot of brain activity that's going on in everyone's brains that I don't know if you would call a thought.
And remember, you're drawing upon memory sometimes as well, because
Yeah.
in order to analyze or formulate your thought, your current thought,
You have to draw on memory.
You have to draw on memory, on your personality, on how you grew up, on a lot of stuff that you have in you, your personality, your consciousness, etc. You're drawing on a lot of that to give me a new thought, which is the thought that you want to convey, right, to someone.
Yeah.
And so you're kind of drawing on all this, whether consciously or unconsciously. It just flows from somewhere,
Yeah.
and that somewhere is this history you have built in your head out of experiences, memory, who knows how many things.
But
that
then
you
it
got
goes
in
to
there.
what you said earlier. Is thought is are we trying to define the product of the process, or are
Okay.
we saying the whole process is?
The next question might put us a little closer. Here's question number 5, okay, for you to entertain. Is information the same thing as meaning? Is thought the same thing as information?
Shit, these are some deep ones. Is information the same thing
As
as
meaning, right? I mean, you talked about.
I would say no.
Hold it. What was the word that you used? Attention,
Attention,
right?
yeah.
So is meaning the same thing as attention? I mean, if I don't pay attention, I don't get the meaning, right? Or I can't even convey the meaning if I don't
Well,
pay
yeah,
attention.
but there's still two different things.
Is it?
You use attention to grasp the meaning, but now is information and meaning the same? I would also say no, because you could have there's a lot of information, but if it's just scattered, if there's no cohesion, I think meaning comes from cohesive information. When you say where it's like a pattern, like this, and then this will come up. That's a sort of meaning. Like 1, 2, 3, 4, 5, 6. That's closer to meaning than just random information. I mean, again, meaning is also subjective. We extract meaning out of information. There's a lot of information in
do
here.
Do we need, in order to have meaning, do we need attention?
Yeah.
So is meaning the same thing as attention? Are they synonyms?
No.
What's the difference?
Meaning and because attention is the tool you use to create meaning, if anything.
Let me give you an analogy, because
Yeah.
I've got that in my book as well.
Hit me.
We have meaning. I had to make a distinction between definition and meaning.
Oh, I want to hear this.
Yeah. Definition is what the prosecutor issues. Meaning is what the jury infers.
Okay.
Meaning is on the receiving end.
I like that.
Definition is on the emitting end.
That makes sense.
And let me give you here an analogy, okay? This is probably the best analogy that you can find out there. Some of you, not all of you are very old, not from the 19th century like me, but there was something called a telegraph, okay? And that's not a telephone.
Telegraph.
It's not a telephone. It's not a iPhone, okay? It's called a telegraph. And they used to send messages like SOS, right? So if you hit 3 times and then 3 long ones and 3 short ones, well, you got did did right? And
I can't imagine someone with Parkinson's trying to run that one.
so here you have on the left, you have the telegraph, okay? So it sends through the wires to these guys on the receiving end. And the question is, what is information? Okay, you have these folks in quantum mechanics, and they talk about transfer of information, and that's clearly an irrational notion. We can't transfer information because information is not an elephant, it's not a rock, it's not something that you can carry and transfer.
Information can't technically move.
Right, it's a concept.
Yeah.
So you can't say you're going to transfer information.
It's like
So-
transferring red.
Right. You transfer it. I mean, so what are we saying really? Well, what we're saying is that you transfer, what you do, you send a signal or some torsion, as I call it. There's a torsion going along the wires. That's not information yet. Information's on the receiving end.
I like that.
It's the prosecutor who issues the SOS, and the jury on the receiving end who makes sense of it, and we call that making sense information.
Could you say that?
Is that what we're doing with thought, with mind?
Are we saying that both definition and meaning, as you stated them, are both forms of information? So they both count as information. What I want to say and what you understand.
But let's keep definition in mind. Yeah. Definition is information only when you formulate it and you're the receiver.
Yeah.
You have to create the definition, but at that moment you are your own jury. You are your own crowd, your audience.
We don't have to go into that, but I'm just saying, like, they both count as information.
Right, and the issue primarily is that information is always on the receiving end. It's what you interpret and convert a signal or whatever into information.
Also on the giving end.
Okay, show me.
That's also information.
Well, we got to do that information then. Information is what you have to make sense of the information for it to be information, right? I mean, if you don't make sense of it, you don't have information. So you have to be the audience. You can't be the actor.
I mean, I think it's also actor because information has something to do with intention. I think, but I might be wrong.
Okay.
But like when I'm here's an easy one. Like when I'm coding, right? I'm the doer, but I'm putting things in formation and putting them in a certain order such that they will be received as information on the receiving end.
Right.
Yeah, but also the intent for it to be meaningful is also a type of information.
What do you mean
meaningful?
Meaningful means that you're the audience.
Yeah. But when you're doing it, you're doing the audience. But you're doing it in such a way that it will be meaningful.
Yeah, but how you make meaningful out of that is because you're listening to yourself.
Yeah, but when the guy's doing the telegraph, not the guy receiving, but the guy doing the telegraph, he's not just doing random stuff. Why not? Because he's doing it in such a way that he or whoever will get a meaning out of it. So would you call that information?
Yeah, but because he's on the receiving end, the guy who's doing it, right? Yeah. He's going to
he's also listening to himself.
Right.
Yeah.
Because otherwise if he doesn't know what he's sending, he's got to be on the receiving end to begin with.
I mean, a funny part of that is, people who are deaf find it hard to speak. And it's kind of that since they can't hear their own thing, it's hard for them to make the meaning.
They don't have the loop.
That's what I mean. They're like the telegraph guy who can't hear his own doot, 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 doot.
So he can't be sending SOS because he doesn't know what he's sending.
He can try.
Unless he knows what he's doing, unless he's already understanding.
Trained in a different way.
Well, he's already received the information. He's already got the information in his brain. Now, mechanically, he goes, ba-ba, beep, ba-ba, right? He can do that. But he doesn't.
Maybe you're right. Maybe it's always the receiver. I'm thinking about it, but you're right. When I'm coding or whenever you're writing a book, you're reading what you wrote, so you know that it has meaning, or that it can be read as you put it down.
What I'm going to do next time you code, I'm going to cut off your hands, and so you.
No. You have to blind me.
Okay, there you go.
If you blind me, then at some point,
and then let's see if you can do your code.
I mean, I could try, but at some point,
have you received any information? No.
That's very interesting.
Okay, so here's another question along those.
Received.
Along these lines, okay, is thought a noun, right? The same thing as thinking.
That one's...
Okay, is thought the same thing as thinking? I mean, let me tell you why. Because thought is an ongoing process. Thought is not a fixed one. And let me prove that to you, or let me give you a good example here, really. Here we have Mickey Mouse, okay, he's walking, okay? So he's walking, but in order for you to have that on the screen inside your mind, inside your brain, right? In order to have that walking there, what you need to do, or what I need to do in order for you to see that, is I got to have all these 10 different pictures, and I'm going to send them one right after another. So in order to have Mickey walking, I have to have 10 of these pictures thrown into your head, right? Or my head, right? And only then can I see Mickey walking. But it turns out that here's Mickey just standing still. All these pictures are exactly the same. And I need all 10 of them and billions more second right after second in order to see him just standing, not moving at all.
You're talking about eyes, our eyes, or what are you talking about?
Well, I'm talking about inside your brain. Okay, you're gonna let's say I imagine a table. Okay,
Yeah.
I imagine a table. The table's not moving, right? And I can imagine the table. Let me get rid of this one. Let's say I imagine a table. So I close my eyes and I say, okay, it's brown, it's made out of wood, blah, 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 and I can visualize my table. If I concentrate long enough, I can visualize the table.
Mine is round.
In order to keep that table in my mind, it hasn't moved. I'm not comparing it against anything. There's nothing else in the universe except that table.
Yeah.
In order to keep it in the screen of my mind up there, like a projector, I have to throw one picture after another, Mickey, in the same table.
I get
The
distracted.
table's not moving.
I lose the table because I get distracted. Like table, something else. Table.
Well, that's why in yoga they tell you, you're one with the universe. You got to think of nothing. So when you think of nothing, are you focusing the screen on black, on dark?
Well, let's stay with the table. Table's hard
Yeah,
enough. But when we're talking about the table, you're saying just to imagine a table, I have to. Well, I mean, obviously it's a process because, like they said in the comments somewhere, if a boxer comes and knocks you out, that table's gone. So there's something that's continuously generating that table until the boxer hits you. Then whatever connection was there gets severed, and there's not a table anymore.
Yeah, but my only point there was that you need the projector inside your brain in order to focus on just the table or the chair or whatever, right? You have only a single object in your field of view and your screen inside your mind because you can focus and say, okay, I see the table.
Yeah.
I see it, you don't, but I see it. But in order to keep it there, I have to have a film of just the table constantly.
What we're saying
so it's not just motion like in the case of Mickey.
We're saying
just
any thought is a process.
Yeah. And so the question is, thinking the same thing as thought, are they synonyms? Because thought is a process, thinking also. So,
what we would say,
but one is a noun, the other one's a verb.
Yeah,
right?
I guess what I would say a thought is, if I had to make a distinction between thought and thinking, is thought is like a sentence where it has a beginning and an end. It's almost like we artificially cut off the thought before that, and the thinking before that, and the thinking after that. Call that the thought.
Is a sentence a movie?
Yeah.
So we have emotion.
Yeah. But I guess what I'm saying is thought is a chunk of thinking. It's a fraction of thinking. Thinking is just ongoing. Thought is when we say from here to here.
Okay, so you're chopping it off, whereas the other one is eternal, ongoing.
Yeah, I think
whatever.
thinking is just it's indeterminate.
Okay, you can separate them like that and say I'm going to use the word thought for the noun because I'm going to chop off the sentence or whatever
In that
idea
sense,
you've got. Right.
It's kind of like an object in that sense where it has boundaries, whereas thinking is just thinking.
So thinking, if I change my thought, I'm still thinking, but I'm thinking of something else.
It's kind of like jumping and jump. Like a jump
One
one because you cut it off.
Okay, so now answer the question. Maybe you got an answer to the question. Is it discrete? Is it analog, or is it what is it?
Digital?
Digital.
What's the difference between the two?
Well, digital is, this is digital, whereas, this is more like analog. Something that analog means that it's continuous, it's, ongoing, which is kind of like thinking, whereas what you're saying, thought, is chopped off, which is kind of digital.
I mean, I would say digital is and analog is just one is electric and one isn't.
No. That's not the context is as follows. You said a sentence or one thought, right? And we chop it off and say this is one thought.
It's like a sentence, yeah.
So
ripping the sentence out of the book.
So that's digital.
Why digital? I don't get that.
Because it's chopped off. It's like it's a unit of itself, different than the other unit. Whereas thinking is more like analog, where it's a continuous process. Even though you changed your thought, you're still thinking, even though it's something else. So thinking is a whole bunch of thoughts, but each one of the thoughts is like digital, where the other one is like analog.
But I guess in the distinction we're making doesn't really change the definition of thinking and thought. We haven't gotten to the crux of the definition of thinking or thought, because they're still the same.
Yeah.
If one's just a piece of the other, we still have to define jump or jumping.
Yep.
Like, what is the physical process of thought?
Well, again, all I can say is we think the neurons are work because of torsion and not because something is flowing, something is traveling.
Another definition we got on thought is it's a past tense of thinking. Like, it's a consummated event. It's in the past.
Like memory.
Yeah, thinking is like in the present. Thought is in the past.
Well, yeah. Yeah.
That could be another distinction.
I cannot think a thought tomorrow.
In ordinary speech. I don't know if you want to really cut down on it, maybe you could say that it's time bound, because it's another version of what I said. Because if thought is a chopping off, you can only chop off consummated events. You can't chop off something that's gonna happen.
Okay, so one thought is different than another thought in that sense.
But they're all in the past.
But
whereas thinking is always in the present. You can't think in the past. You can't think in the future. You're always thinking in the present.
I was thinking.
Yeah, now we're back to common talk. I don't know if you want to use that language in science, you might get it. Then you can't use it consistently.
See if we have any questions from the.
I mean, I'm getting most of them. Yeah.
Let's see.
I'm kind of trying to bring them into the conversation. As is.
We give up. We have no definition. Sorry to keep you interested in the subject,
but also in the comments, it's usually about electricity in the brain. I think we can all kind of agree that the notion of thinking has something to do with electricity in the brain. But now the definition of thinking or definition of thought, that's where it gets muddy, because it depends on how much you want to cut off.
Well, I don't think it's. I think the analogy is the only one we can use here. And again, is you have the brain, which is the hardware. You have the software, which is who you are in a sense, how you were raised, what your DNA tells you to do, etc. And so you have certain thoughts in a given way because you're already somewhat hardwired that way, or you have your experience or whatever you want to fit in there. And then what is the product? Well, in the case of a computer, the software is not the product. Software is what tells the computer to give you a product. Mm-hmm. And the product is going to be a number one, a number two sentence, whatever you ask it to do. And that's more or less where thought comes in. I'm saying the neurons are the hardware, right? You can take that to cells, to brain, whatever. It doesn't matter. You can chop it off wherever you want. That's the hardware. Those are the atoms, right? And you have these instructions which you already have in memory because you were raised in a given way, or you are in a different way because of your genes or whatever. Yeah. And that's what's going to kind of program. That's your program. That's your programming. You're telling the neurons to do something because
to fire in certain patterns.
That's why I call it will and volition, because you're kind of telling the neuron, do this, do that. You know, you can change your thought from one second to the other. And what are you doing? You're giving instructions essentially to yourself, to your neurons, to do something, to think about something else. So I'm saying that volition, will, that's kind of what the software is. But then you have the product. What is the product? The product is thought. Now we have this thinking, this thought out there. What did you produce? Well, when you produce thought, you haven't produced much.
It's something that I saw or heard,
right? But
without seeing or hearing it.
But you produce something because that's going to be a feedback loop that's going to affect your software, which is going to affect your hardware. It goes back.
There's a lot of feedback.
Yeah. So all I can say, the best analogy for all this is that thought is kind of like the product, like in the case of a computer, the product of what you are trying to get out of it. And that's more or less what thought is. It includes analysis, it includes memory, and a lot of stuff goes in there. But eventually you could produce this product, which is the thinking, the momentary thinking, past thought, right? And now you got that, and you can use that in a sense that it can now form a feedback loop where you affect your software, which is going to affect your hardware.
That's why brains are complicated.
Yeah.
It's that feedback loop that makes it very complicated.
Now, defining it, I don't know, a product, information, any of those for now, I think should go into the definition. but that's going to be a tough one. It's going to be tough getting a perfect definition.
I think if
you can use consistent.
If it were up to me, I would definitely try to make a distinction between bioelectrical processes in the brain and thought, as in something you can convey or something you hear or see that isn't
which is the product,
which is a very human thing, but bioelectrical chemicals in the electrical impulses in the brain, dogs and I don't know, grasshoppers have that, but thought as we understand it, as in like information, maybe information is wrong, because information, obviously a grasshopper can also,
has some level of information.
It can dissect information out of its environment and do certain things. But
all these animals really
maybe you could just say they're different levels of thought.
Brain, you have different abilities and capabilities of brain.
Maybe there is no difference between thought and biochemical things in the brain. Maybe that's just so
in my book, I define intelligence as essentially almost equivalent to life, in the sense that the first living entity is the cell. But what is a cell? Cell is a CPU. It's the first unit that that can organize information or instruct different parts of its body. The cell instructs different parts of itself to do certain things, to do certain tasks. And it's like the CPU that tells itself. It's, where the cell ends, tells anything in there what to do and how to function. And so that's more or less, in a sense, what intelligence is. So every animal in the universe has intelligence. Plants, I don't think they do, because they don't have a nucleus. And so we have they don't have a CPU. So I think that's the difference between a plant. We always say a guy who lost his head, he's a vegetable. Why? Because he no longer has that nucleus in there, right? That's the difference. And so intelligence essentially is the cell. That's the first unit that has intelligence, and anything that has an animal cell is an intelligent being. Okay.
One last question.
Yeah.
Here we got a question. If body is the hardware, right, the brain,
which is the first question,
mind is the software, and thought is the software output, where would consciousness fall under those?
Consciousness would be, I'd say, the output. So it's closer to thought. Yeah, I would say if I had to guess, put my bet, I would put it with
where does attention fall in there?
Well,
or is that a fourth
one?
That
was a good point that you made, because in order to have the information, if information is a synonym of thought, right, you have to have attention. Can you have thoughts without attention, without pain? I mean, here you have your screen inside your brain.
Yeah,
right?
We're all very interested in this screen.
Right, you get the
whatever
screen.
This thing is,
whatever's there, it's one thought at a time.
Yeah.
But in order for you to think about the thought, about what you have there, what you have on the screen, you have to pay attention.
Yeah.
You have to be a spectator, but whatever you have in your brain doesn't matter. You always have something in your brain. You always have something on your screen. And if I tell you, what do you think about now? Color blue.
You can always say something.
Right. You'll say something that you're thinking about right now. Why are you thinking that? Because you're paying attention.
Or that you're aware of, I guess.
Meaning attention. I think attention is a very important word there.
I mean, attention is the big one of meditation. That's the one that they harp on.
I don't know if thinking would fit with attention, but thought obviously does, right?
Well, we both look up like, I do have to think about more. Think more on it.
Sorry, guys. We're very ignorant. We don't know what.
Yeah, we tap out. I tap.
We got a lot of homework to do here. Okay, all we did today was brainstorm. So just please forgive us.
More questions than answers today.